Okay, let's go through the 3-3 notes. This is proving lines parallel. So in this case, we are going to talk about the converse of the corresponding angles theorem. So it's going to sound very similar to what we did before. It's just going to be the opposite. The sentence is going to be in the opposite way, like we did the converse and the conditional in chapter 2. So the converse of the corresponding angles theorem says if two lines in a plane are cut by a transversal and corresponding angles are congruent, then the lines are parallel. Okay, here's the abbreviated version. They already have that for you this time, so you don't have to write that this time. And again, it says if corresponding angles congruent, then the lines are parallel. Okay, an example of that would be that in this particular case, if I know that I can find some corresponding angles, so if I see angle 2 and angle 6. Now remember, they have those names whether the lines are parallel or not. If those are in the same relative position, those are corresponding angles. Now, if I know that these two corresponding angles are congruent to each other, I would therefore know that these two lines must be parallel to each other. Okay, so kind of an example I can say from that is that if angle 2 is congruent to angle 6, then M would have to be parallel to N. Okay, so that's just something that I know. If the corresponding angles are congruent, the lines must be parallel. The converse of the alternate exterior angle theorem is saying if two lines in a plane are cut by a transversal and alternate exterior, angles are congruent, then the two lines are parallel. Okay, so again, here's our abbreviation. If alternate exterior angles congruent, then the lines are parallel. And if I look up here to find some alternate exterior angles, then I can see, okay, angles 1 and angle 8 are alternate exterior. And if I know that those two angles are congruent to each other, then I therefore know those two lines must be parallel to each other. So again, I can write that out. If angle 1 is congruent to angle 8, then I would know that M would have to be parallel to N. Okay? All right, let's go ahead and move that up. And there are two more. So there's two more theorems that pertain to this. So, you won't be able to see our picture this time on the screen, but you have that on your paper that you can kind of refer to. So, same idea, converse alternate exterior angles theorem just says if two lines in a plane are cut by a transversal and alternate interior, angles are congruent, then the two lines are parallel. Okay, again, here's the abbreviation for that. And again, if you look at your picture, you can see 3 and 6 are a pair of alternate interior. So an example I can put is if angle 3 is congruent to angle 6, then M must be parallel to N. Okay, again, you could list the other alternate interior angles, which are 4 and 5 as well. I'm just putting one example for now. Then the converse of the same side interior angles postulate. Both of those. If two lines in a plane are cut by a transversal that form same side interior angles that are supplementary, then the lines are parallel. Okay? The abbreviation of that is if same side interior angles are supplementary, then the lines are parallel. And the example of that says that if the measure of angle, this one looks a little different, 4, plus the measure of angle 6 equals 180, then M must be parallel to N. Okay, we're not saying they're congruent this time. We're saying that 4 and 6 add up to 180, so therefore the two lines must be parallel. Okay, so let's look at some examples of this. So in this case, it says, what is the transversal? What lines would be parallel? Justify your answer. So again, a transversal is a line that goes through two other lines that also go beside the two angles that we're dealing with. So if these two angles are the ones that are marked, then I know that is the transversal. So I know that the transversal is OU, okay? And I can call that a line, all right? And then I therefore know that the two lines that must be parallel then would be these two that make up the other side of those angles. So really I'm not dealing with this part of the picture. So if it helps you to scratch it out so you're not focused on it, then a lot of times that's helpful. A lot of people also like to kind of highlight what they're dealing with. Like, okay, here's my transversal that goes beside the two angles I'm dealing with and goes through two lines. And therefore these would be my two parallel lines because they make up the other side of those angles and go through the transversal. So I can name those as RP and SQ. Okay, and then I can say, okay, well, what kind of angles are those two angles? Well, they're alternate exterior, so I can say it's the converse of the alternate exterior angle theorem. But again, when we write this reason in proofs or, you know, on our homework, so that kind of thing, we don't want to call it the converse alternate exterior angle theorem. The reason is a lot of people will get confused of which one that actually means. So we found that it's easier for people to remember it if they write it out. So the way that I want to think of that is, what did I know first? I knew first that these lines were congruent, and from that I knew that the lines were parallel. So when I write my little sentence, I need to say it that way. I need to say, if alternate exterior angles are congruent, then the lines must be parallel. Okay. All right, now let's look at another. If we look at another, we can see here that this would be our transversal because it goes beside both angles and goes through two lines. So we can just call that transversal T. We can see that the two parallel lines then would be D and E because they make up the other side of that angle and go through the transversal. So there's D and E. And therefore, the line that we're not dealing with is S. If you want to cross that out, then a lot of times that's helpful. So now I can focus in here and think, what kind of angles are these? And yes, they're corresponding angles. So I'm dealing with the converse of the corresponding angles theorem. And then again, if I go ahead and write that out, again, I know they're corresponding angles and I know they're congruent, so that's what I want to start with. If corresponding angles are congruent, then what I know from that is then the lines must be parallel. Okay. And then the last one like this is, again, I'm looking for that transversal, the line that goes by both of the angles. Sometimes it helps people to figure like this to extend it out a little bit. And then I can find my two parallel lines that make up the other side of the angles and go through the transversal. And therefore the line that I'm not dealing with is BC. So my transversal this time is AD. And my two parallel lines then are AB and CD. Okay. And from there, I've got the converse of the, you know, what kind of angles are these? Alternate interior. So alternate interior angle theorem. Okay. And again, from there, if I go ahead and write out what that theorem says, I'm again starting with the alternate interior angles congruent. If alternate interior angles are congruent, then the lines must be parallel. And that's that. All right, so a little bit more on the next page where we can actually use some of this information to solve. And so if you start looking at the next problem, we can see that they're giving us some angle pairs. They're telling us that M and N are parallel, so I think it's helpful to mark on your picture that. and then find the measure of each labeled angle. So if we look here, we can see, okay, here are two angles, and what kind of angles are they? Well, they're in the same relative position with respect to the two line, with respect to the transversal, they're corresponding angles. Since the lines are parallel, then these two angles must be congruent. Oh, actually, I'm saying because they're corresponding angles, it's saying what would x have to be for these two lines to be parallel. So in this case, I'm saying, okay, if I set these equal to each other and solve for x, then whatever that x value is would make these corresponding angles congruent, and if those corresponding angles are congruent, therefore these lines must be parallel. So I know that I would need to set them equal to each other. And if I go ahead and set those equal to each other, I can solve for x and find out, again, the x value, add 11 to both sides. We end up with x is equal to 15. Okay, so I've gotten x is equal to 15. I just need to pay attention. That's the x value that would make those lines parallel, but then it's also asking me to find the measure of the labeled angles. So I can do that off to the side here. I can say, okay, the measure of angle RSU is 8x plus 4. I now know that x is 15, so I can go 8 times 15 plus 4. And if I go ahead and figure that out, then I end up with 124. Okay, if I go ahead and now figure out what angle STB is, then I've got 9 times 15 minus 11, and that gives me 124 as well. And I want to see if my answer makes sense. Does it make sense that they'd be the same? Yes, because they're corresponding angles, and we found the x value that would make them congruent to each other. And so that would make sense that the two corresponding angles would have the same measure and be congruent, and therefore the lines would be parallel from that. Okay? All right, one more. Get that moved up here. Or actually, example 3, but it has 2 in there. So if we go ahead and look at that, then it says determine the values of x so that r is parallel to s, then find the measure of each labeled angle. So again, we're going to look to see, all right, what kind of angles are these two angles? They are alternate exterior angles, so they must be congruent if the lines are parallel. So we can set those equal to each other. 2x plus 6 is equal to 42. And we can go ahead and solve from there. So we get 2x is equal to 36. And we can go and divide by 2 on both sides. And we can get x is equal to 18. Once we do that, we can plug in. We already see that this angle is 42. If we go ahead and plug in here to verify that that gives us 42 as well, 2 times 18 plus 6. Then, yes, we get 36 plus 6, which is 42. So again, 42, if both of these are 42, then I therefore know those two lines must be parallel to each other. All right, last one is, again, I look at this to see what kind of angles are they. They're same side interior angles. And what do I know about same side interior angles? If the lines are to be parallel, and they would be supplementary. So that means that they would add up to 180. So 3x minus 17 plus 98 must equal 180. And I can go ahead and solve from there. I can combine my like terms together. Negative 17 plus 98 is 81. I can go ahead and subtract 81 from both sides. And I get 3x is equal to 99. And then I can go ahead and divide by 3 on both sides. And that gives me x is equal to 33. Okay, once I do that, again, I already know this angle's 98. If I want to find this angle, I can come back up here and say 3 times 33 minus 17, and that gives me 99 minus 17, which gives me 82. So that answers the other part of the question. You know, they were asking for x and for the missing angles. Okay, so again, let me know if you have any questions and I'll be glad to help you out.